integrating these assistants both visually, in auditive ways, and in chat interfaces, textual modes. So I'll show you a little bit what I'm doing. I'll show you a little bit what our partners are doing, what our clients are doing. And of course, try to relate that as much as possible to JavaScript, because this is my main programming language. Very briefly, these numbers are exaggerated, but more or less 10 years in EPAM, it's actually eight rounded up. That's how much I've been in Bulgaria overall. And I've stayed there for this time, and I've been into machine learning, and in general, I've been programming for quite a lot of time. Dealing with mostly the same problems that all of you are dealing. So trying different editors, there's nothing that works for everything. Something is happening to HDMI here, all right. Using different operating systems, nothing perfect, especially nowadays, right? Nowadays, it seems like every OS is broken in one way or another. And of course, looking for the best programming language. And here I should say JavaScript, because this is a JavaScript event, so obviously the best programming language is JavaScript. When I do .NET events, I said .NET, so I try to get some attention. But JavaScript is special because it has this feature, and apparently I have it on the slides as well. It produces undefined on the click of the button. It's quite nice. And I've recently converted to the Church of AI, so I was a person that completely refused to say AI at all, artificial intelligence. I'm into machine learning, but I didn't agree with the AI part. But I did. There were things that made me change idea and try to embrace the subject. So mainly the notion that compression is intelligence. If anybody remembers the Turing test as well, this seems to be a thing of the past. So we have very evolved models where you think that you would be able to identify, but I guarantee you we have models that you won't be able to identify that they are AI and not actual humans chatting. And I have this friend that says, you must have seen something for you to change idea. You definitely seen something that's not accessible. He's kind of a conspiracy theorist a little bit, but he's like, you've seen something that we haven't, that's why you changed the idea. But I haven't. It's just all the models that are accessible to everybody. And I will show you how to integrate these models, how to use them. If you want to dig into this subject of why compression could be intelligence, you can look into Kolmogorov complexities or Monov distributions and the Hutter price. A quick recap, what we are doing with machine learning and neural networks. We have these two parameters, W and B. We try to manipulate them. This moves the line, right? Moves the slope, the intersect. And we try to match it to our data, our blue line. We try to match the orange line to the blue line. This is what we do with machine learning. But this is very linear. We don't live in a linear world. We live in a more complex world. So I hope that, are you getting interruptions on the screen? Because I have some here. All right. So this is all we do, but this is linear. We cannot get a lot from this. We can get very basic behavior. So and that's what we call a neuron. So that y equals wx plus b is a neuron. And we try to combine many of these neurons in different structures, in different layers, connect them differently to essentially break that linearity. The way we break linearity is with the activation functions. So a neuron will say yes or no to a different grade, and we would choose whether to activate based on our activation functions. And the activation functions are also something that we learn by optimizing the results of the model. So we train, and eventually we hope that we minimize the error and approximate our predictions to the train and test data sets. So this is very simple to understand. Remember, these are the same y equals wx plus b functions, and we have this neural network where we connect them to each other. If everything is connected to each other, to everything else, we call this a fully connected layer. And if we play with these architectures, with these designs, for example, we have more neurons, and then we decrease the amount of neurons in the next layer, and we decrease it a little bit more, and then we try to actually make the same prediction as the input. So we started with a small amount of neurons to a bigger amount of neurons, and we optimize this network. So we just play with the architecture. There's mostly nothing new here. Actually, what happens is that we compress knowledge and we learn how to decompress knowledge. So we are compressing our data set in the middle. We have a compressor, an encoder on the left, latent representation in the middle, and then we decompress. This is not very much different than zip, than different compression algorithms, than gzip, and so on and so forth. And there was a paper actually that reproduces a lot of these results just using gzip as well. So it all relates to compression and data. So this is kind of to have a common understanding with what we're doing. 3 important papers, if you want to dig a little bit more. They are very important because one enables all of this. It's called Attention is All You Need by Google in 2017. It's a very easy to understand paper. I think it's just like, it should be like 9 pages long, not more than 9 pages. Then you have this one for visuals. So how to take this attention mechanism and and transformer mechanism and apply it to images. So essentially, we change how we encode the image to get the same results or good results in the prediction, and one that applies an architecture for audio. So these are different architectures of the network, mainly in the encoder and decoder part, that essentially enable us to share this representation we had in the middle between audio, images, and text. You don't need to know all of this, but it's good if you have a basic understanding of what happens, because all of this is actually hidden behind mainly 2 APIs nowadays. The first API is what we call the chat API. And this is essentially what OpenAI started with, so everybody else kind of followed afterwards. So every vendor out there is mostly implementing these 2 APIs in one way or another. Maybe one parameter is a little bit different, but this is the main structure. It's very simple. If you can make an HTTP call, you can start integrating an AI assistant or a model in your application. And the other one is the generation interface. Difference is not that big. You can emulate the chat interface with the generation interface. The chat just gives you this conversational style where you have multiple rows in the conversation, and now it disappeared because of my computer, of course. I'll just share I'll list some subjects so that you're familiar with these names, but they are not required. Some frameworks, MLX, this is what you would use if you had Apple Silicon. So later we are going to build on this. So this is all hidden behind these 2 APIs. But again, this is for you to understand what are the ingredients. MLX is what will be used most of the time if you're on an Apple machine. JAX is a training framework, planned to be kind of the substitute of PyTorch at some point. It's much cleaner. PyTorch has existed for a lot of time, and it's a little bit bloated right now. And TinyGrad is interesting because it's a small project, and it has a graph. I wouldn't say it's the first, but it has this graph approach to things. So it's modeling all the operations as a directed acyclic graph. And it's also interesting because it's keeping all the vendor driver things. So it interacts directly with the GPU for training. In terms of runtimes, Llama C++ is a project mainly started and developed in Bulgaria. And this is used everywhere for nowadays for AI, large language models, let's say, for large language models. It was one of the first projects that actually started quantizing models, making them smaller and making them usable on machines like this. So if you have a machine like this, you will be able to use a lot of these engines. And everything I'm showing you today is actually running here. I could as well disconnect my connection to the internet. OLlama, now of course this is C++. It's very easy to compile, but you still need the whole toolchain to compile. So, and depending on whether you have an NVIDIA GPU or an Apple machine, you would need to use different toolchains, and compilation then gets a little bit tricky. OLlama ships Llama C++ already compiled for your operating system, and it exposes the same APIs, and you can use OLlama just by downloading an application and installing it. I like this one because it has an interface similar to Docker containers, so you'll see the commands are very, very similar as well. Llama.File, a very interesting project you should also check out. So Llama.File is also using Llama C++ underneath, but it builds a single binary that is then able to self-compile itself or to self-compile the optimization parts and to also run on every operating system. So you have a single file, runs on macOS, runs on Linux, runs on Windows. I'll show you this later. VLLM is an inference runtime which can also get models from different places, like Hugging Face, Transformers is a similar one, but in Python. So it gives you, and as you see later, they also are building a JavaScript library now, Transformers.js. And DoiNNX is another runtime which has this graph approach to sharing models. It's an open runtime and an open specification. Some of the models that you should know about, but there are many, many others. I couldn't cover all the models that you could use, but if you follow some people on social networks, you would get an idea of which models work for what and which don't. Personally, I like Gemma 2. This is a model by Google, a multilingual one, does very well in Bulgarian, so I end up using it very often. You already know probably about Llama 3.1 and 3.2. These are by Meta. And 3.2 especially provides very small models and models that you can run on the edge. So if you have very limited hardware, you can run Llama 3.2. On that, you can also do it probably without any kind of acceleration. And Mistral, because everything is open source under Apache 2.0, including the training data. Visual models, we don't exceed in open source very, very much here. There are some models that are doing well, depending on the task that you need to complete, but they do require more memory in general. But you could try something like Polygemma, you could try Llama 3.2 Vision, which is, you couldn't because it's forbidden in the EU. But let's say if you happen to not be in the EU in that particular moment, you could try it. It does well on different tasks. Lava is one of the first visual open source models. Doesn't really do very good in OCR because most of the tasks you end up doing visually is probably looking at documents and trying to understand what's in those documents. And what does very well in OCR is actually Qwen2 VL, but this is a very big model, so you need an almost inaccessible hardware now to run it, but it produces very good results. Pixtral by Mistral is their vision model, and SAM2 is for image segmentation. In terms of audio models, not doing very good here as well in open source. By far, the best audio models for example, text-to-speech are proprietary. So you have 11 Labs, which has one of the best models. But in open source, we try to get away with Bark, with OpenVoice. And we actually do really good with speech-to-text, so the other way around. And this is where Whisper comes in play. I'll show you Whisper as well. So Whisper comes in 3 different sizes, and it's quite usable on commodity hardware and does a good job. Also in Bulgarian or in other languages. So we can test one of these models. So I'll try to ask here something like, is this a Cornell box? So using that same API, I will send this, this image and the prompt to a model. Using that API, it just has an image parameter in addition, and I'll get the response back. I don't remember which key, but let's try this one. So first time it needs to load the model.
Is this a Cornell box? Yes, the image appears to show a perspective of a Cornell box.
Right, so this is now using Lava, the Lava model, locally.
The box is typically set up within a room and viewed from a specific
And
angle.
this one is, so one thing I didn't do in this presentation is have something to disable.
Showing how lighting affects the appearance of different
So we need to wait a little bit.
surfaces.
Oh no,
Hello everyone, I'm Sam Alexis, and I'm thrilled
this
to
was
be
not
here
supposed
at
to
JS
happen,
Talks
sorry
today
about that.
to talk about a topic that's very
Let's
close
try
to
to,
my heart, integrating AI into our applications and
let's wait
workflows.
for it. I'll fix this. So by speaking, I'll now record my voice. I'll send it to Whisper. Whisper is going to do the transcoding from speech to text. And then we'll send it to an AI assistant and get the response back. Hey, I'm doing this presentation, but I don't really know what to say. Suggest something for the crowd. Okay, so that's rather long. I think I need to mute it.
Here are a few suggestions for Sam's presentation. 1. Start with a hook asterisk.
All right, so I'll just mute this one. But you see the transcoding was almost, actually the transcoding I would say is near to perfect. It's almost always very good. So one last thing is functions or tools. So besides doing images, audio, and text, we also have the option to use some form of token control to call functions and provide the results of those functions within large language models prompt. And it's great that I didn't start my timer, so I'll try to be on time here. You can develop custom functions. For example, if you imagine how a model is trained, it is trained on a particular date and time. So if you try to ask the model what time it is, it will tell you the time of when it was trained, or the last time it told that it was the correct time. So you want something like a function to be able to get the current time and inject it inside the prompt. I'll plug a few things that my company is doing. So EPAM AI Dial abstracts all of this in enterprise APIs. So if you want to deploy it in an enterprise setup where you have enterprise-grade authentication, so it's integrated with Azure AD, it's integrated with Azure very well. You can check out the EPAM AI Dial. It's an Apache 2.0 project, so it's properly open sourced. And another interesting project that we are doing is EPAM GenAI. You probably saw it outside. So this is an Unreal Engine application that's using a lot of these models similarly to what I did here, but it also uses some high-resolution metahuman models to try to reproduce, try to display properly a virtual human. and we have several grades of quality with which we can run it. Unfortunately, outside we are running it at very low resolution, but maybe we can get more powerful hardware to do a proper demo. Nevertheless, if you want to interact, it's outside, you can speak to it and ask it pretty much what you can ask. Behind it's using OpenAI, so what you can use ChatGPT, what you can ask to ChatGPT. A project that I really like is Notebook LM. You can throw in documents and you get a nice summary of what's in those documents, and you can ask questions. It uses actually this model, it uses the audio LM paper to produce a podcast between two people talking to each other about the paper. So it's very easy to maybe learn something while you're doing something else. So let's start with Ollama and Whisper file. Locally here, so you go to the Ollama website and you download the application. Once you install it, you have the Ollama command. So as I said, it's very similar to Docker. So how do you list Docker images? Docker image list. Well, here you do Ollama list. So it shows you all the models that are installed. If you want to pull an image, you can do Ollama pull the identifier of that image, and it is going to download it. If you want to run an image, you can do Ollama run, the name of the model. I'll run a smaller model, like 3.2. And we can ask something. It's amazingly fast because it's a very small model. If you have a bigger model, it will be slower, and then you need to check how much of that model you can fit into your machine's hardware, or how much money you want to spend, how much do you want to pay in energy. So large language models are not just about having very powerful hardware. It's a trade-off that you need to decide on. So how much do you want to spend? Can you get away with a smaller model? Not always the bigger model is the best, but generally the bigger model gives you the best general results again. So if you have an expert model, then you can get better results with the smaller expert model rather than a generic bigger one. And in pretty much the same way, you can add images to Ollama. It also works with vision models. You just need to give in the path to the image, and Ollama is going to recognize that and encode the image. But this is a command line interface, so many people try to stay away anyway. This exposes an API. So already on this machine, I have an OpenAI compatible API endpoint, the one that I showed you earlier, just by running Ollama. It has the API running. And about Whisper, here I actually had it already launched, but Whisper file, so Whisper is the model, and Whisper file is that model compiled with Llama file to be able to run anywhere. So you actually spot some very strange things. I have a .exe extension, but I'm somehow able to run this on Linux, right? So how does that happen? And I'll tell you how, but you run this, you can pass some accelerator flags. So in my case, it's an NVIDIA GPU, and then you can pass some flags about the audio format that you expect. And this runs. The way it runs, it uses some hacks around the headers of executable files. So essentially, it compiles it uses a cross-platform compiler and runtime that's called Cosmopolitan, and it does some tricks to essentially load in the right parts of that program for the particular operating system where it's being executed, or the so-called portable executable. So you run Whisper, it starts an API, or you can also just pass files directly and it will do the transcoding. It has some more flags. So you can check all the flags. For example, you can give it a prompt, right? So last time I was doing a similar talk, I had a question here. I tried Whisper, but it didn't work. But you can actually steer the distribution. You can steer the statistics in a direction that's more that's closer to what you're doing. So if you're doing something particular, you can prompt the model to essentially pay more attention to those to that context. So I'll just resume that. I don't know if I need it, but just started as it was. And Ollama also has a JavaScript library. If you don't want to make the raw HTTP call, you can actually use Ollama.js. It gives you the same chat and generate methods similar to the OpenAI JavaScript library. Now, one tool that, so these are all tools that allow you to do large language models, but they are very far away from your development environment. So if you want to be closer, you can try something that integrates with VS Code. So I'll show you Continue quickly. Continue is a VS Code extension. So you can install Continue, and when you install it, it shows you the setup screen. I have it here on the right. So this is already the Continue interface. It shows you an interface where you pick whether you want to use OpenAI, whether you want to use Anthropic, or whether you want to use something local. In my case, we're using local. And here I can already interact with the model, and I can choose between different models that I have installed on the machine. But it also has this possibility to start doing RAG, retrieval augmented generation. So if I do @ and it doesn't work every time for some reason, and I have no idea why, by the way. Let's try again. Sorry. Secondary sidebar. Nope. Well, then you need to trust me on this, but essentially when you do the @ symbol, you have a drop-down menu where you can choose whether you want to give a particular file as a context to continue, or you want to give the entire code base. Or maybe it's probably because it's not indexed. So the first time you set up, you go into, it's actually index complete, which is strange. So the first time you install Continue and set it up properly, it needs to index your code base. So you'll see here the process of indexation. In my case, it's actually done. And they also launch a very nice tutorial, a quick start that you can look at here. This is the interface I was referring to. So you can choose best experience, like using the Cloud 3.5 model, something for autocomplete, or you can just go local with Ollama using that local API. This might depend on your client's requirements as well. So if you're working with somebody that doesn't want to have their data leaked, you can use these local models. In my case, Llama 3.1, Qwen 2.5, Coder, and should be connected. So let's try this again. Okay. So this is the drop-down. You can choose to pass some files to the prompt, the entire code base. You can write your own content provider. So it's a very simple JavaScript function where you decide based on the prompt what kind of files to inject or search for. So you can add more context providers, particular folders. You can get the output of the terminal. So inside VS Code, if you have some error, you can pass that output directly to the model, and you can ask what is this error about and how to fix it. In our case, we are going to ask so this is my presentation on the left. Everything is done as Markdown documents, so I can ask what API endpoints are included in this presentation. Right. So it's going to search. So this is the right part. It searches on the entire code base for similarity. And then it tells you which documents are going to be used. So we use the API slide, we use the DIO slide, a proxy slide, and it tells you that you essentially have these APIs, and we can further ask, sorry, but I also have this light that's shining directly in my face, so it's a bit hard to see. Generate an example JavaScript code. Something like this. So this is what we had on the slides, but now it's producing code for it. And it can also work with your open files. You don't need to only use the interface on the right. In your open files, you primarily use Control-I and Control-L. So if I start a new session here, I can select the code that I'm interested into and do, it should be actually Control-L. And I can ask, what is this function about? So now it tells me it's a bubble sort. I didn't even know it's a bubble sort because I didn't have time to look at it, of course. But you see how these become useful, and they can help you recognize pieces of the code that are otherwise undocumented. You have no idea what they do. This is already a booster, an accelerator. And then we can ask it to change things. So if I select this code, I can do Control-I. And I can say, as in the quick start, make it more readable. So it's going to produce some suggestions on what make this code a little bit more readable. In much of the same way, we can ask, is there a bug in the code, fix the bug, and things like that. This doesn't mean that you shouldn't be reading your code. You always should be, but the idea is that it accelerates you. So you can then decide per modification whether you want to accept or reject the change. All right. So this was continue, not a lot of time. VS Code AI Toolkit, similar to continue, but it has a slightly different purpose. So it's again an extension for VS Code. It's by Microsoft. I have this tab on the left. So it tells me what models I have installed. I can connect it to OpenAI, to Anthropic. I can connect it to my local Llama, as you can see here. And I can query my models in much the same way with the user interface. Now it gives you a little bit easier control. In Ollama, you have the same controls, of course, but here you have a user interface where you can decide on the response length, on the temperature. You can give some system prompts. You can also pass in documents if it's supported. So I'm not going to waste your time with this anymore, but this also gives you fine-tuning. So this is kind of, I guess, what differentiates it a little bit. So if you actually create your data set in the AI toolkit, if you create your own data set with the example responses or the example data that you have, you can train a model. You can also train it locally. And as I said earlier, this model is probably going to perform much better rather than generic statistical models. So these now become expert models. All right, LM Studio, we'll go very quickly around this one as well. So probably from here. So you download LM Studio and you launch it. You can kind of see the same pattern repeating and repeating again. I'm just changing the application, connecting it to the same backends so that we can reuse and share models essentially. So this is how LM Studio looks like. I'm pretty sure that in order to load it, I need to unload some of the other models, but let's see. And you also saw that I have control, it actually loaded. I have control over the parameters, how long is the context length, how big is the context length, and other parameters. Context length is actually very important, and as you probably already know or are about to find out, and this is what mainly the experience varies by when using LLMs, is that at some point you exceed the context length of that model. So it's kind of like the model forgets everything you ask in the beginning. So if you gave some prompts, if you exceed the context length, these prompts just disappear. They don't exist anymore because there is not enough memory to encode that. So your experience is going to vary a lot just by the context length. So pay attention to it. Unfortunately, this is very often a showstopper. So sometimes we have a lot of knowledge or examples we want to give to an LLM, and the context length is where we hit the ceiling. And also, one thing that I had to find the hard way, even if you had enough memory, all the models, there isn't a single, well, there are 2 or 3, and they don't work all that well, but most of the models are trained on a context length of 128,000 tokens. So if you exceed those 128,000 tokens, you're now into a dimension that nobody has trained. So yes, you can have that context length, but because it's not trained, you're going to get garbage out. You're going to get random predictions. So with LM Studio, we can also attach documents. So I'm going to upload a file. It's going to do RAG on it. I think this should be the audio LM, or it should be the audio LM paper. But we can ask, what is this document about? So it's going to RAG on the document, try to find relevant information to response, and it cannot find any relevant information. So we should ask something else. This is a very good example, by the way, that RAG doesn't always work. So RAG is going to find semantic similarity. It's going to search in the document much like a Google search. And if you don't do the right search, it's not going to produce results. So I should probably better ask, what is the title then? It didn't, I think it didn't get the document, which is strange. No. Well, I have no idea what I'm passing here, so let me choose another file. So we can choose the attention paper. And if it doesn't work, we just move on, because again, this is LM Studio specific, so I have no idea why it's failing. But you can do these same approaches in other tools as well, so I can do it in Continue and so on. It's probably something with the LM Studio setup that I have locally as well. But I think it makes a very good point. Just because you can do RAG, it doesn't mean that you are going to get the right results. So these methods still require human intervention, and they are, for the most part, they cannot be left unsupervised. They especially fail if you try to enumerate something. So if you ask, what are all the documents? This is already the wrong question. It's going to fail for sure. It doesn't work that way because it's doing this Google search. All right, LM Studio. So one point I wanted to make here, and it's what I'm doing in this presentation as well, you can always inject your proxy between the tool that you're using and the model runtime provider, right? Because they kind of have the same API. You can basically create your own API. This is like a man-in-the-middle attack, essentially, right? But it gets the job done. So you inject yourself between the tool and the runtime, and you can change the prompt, you can inject things, you can remove things. This is how we can also do some moderation on the content and on the responses. And this is an example of a Node.js endpoint that does that. So it just gets the request, changes something, and then returns the response. Because again, even if the tool that you're using says that it's only compatible with OpenAI, at the end of the day, the API is the same. So you just change the address. You point it somewhere else. This one is kind of interesting if you have some spare time. It's a way to also run the inference locally in the browser using WebGPU. But I wouldn't spend too much time because the model transfer takes way too much time. So it's not practical, but I think at some point, maybe it will become practical, especially with 1-bit models. So there's a lot of research being done into being able to quantize to 1.5 bits. I think it's 1 bit, 1.58, something statistically, so on average. So we managed to reduce these models a lot. And as we train them properly, they will become usable in the browser, most probably. AutoGen, let me see if I have time for this. So I'll try to speed up. Maybe just mention what it is. So you know how a model is going to hallucinate or is going to essentially not provide you with an answer, or maybe it wasn't even trained at all on that data, so it has no compressed representation of that knowledge. AutoGen is an approach where you basically stuff many of these models and you try to make them play together. It's quite interesting. So you have different expert models. You can have a programmer, you can have a manager, you can have a, I don't know, a Scrum Master probably. Something you can have as well. You can have somebody that searches the web as an agent. So this is an agentic framework. And you combine them together to produce the desired result. So I'll show you this very quickly. Can I quit this? Yeah. Right, so AutoGen comes also, so this is another framework by Microsoft Research, so it's currently under development. But it also comes with AutoGen Studio. So you can use it as a Python package, or you can use it with this user interface. So I'll show you just the idea with the user interface. I'm essentially running this command. So everything is installed and you run AutoGen locally. I really hope that it remembers my configuration. Right. All right, so this is what I was testing it with before, so I can probably delete this. In AutoGen, you can have many models, so they can all use a different configuration, different context, a different provider, and essentially a vendor. A provider. So you can use OpenAI, you can use Anthropic. I configured them. I think this is my local one this is my local one. So I just pointed it to Ollama locally. And then you configure agents. You can have a default agent, so this will be your helpful assistant. It's instructed in a particular way, but you can also have other agents. And each of them can use a different capabilities, different models, depending on what you're trying to achieve. So for example, I think we can ask it something like, I'll make it use NPM to make sure that it uses the package JSON maybe, and maybe an external, what do you want, some external library. Let's see what we can use. Let's start with this one. Let's see what it produces. So I'm querying the agentic framework, and it's going to produce outputs using many different agents that are going to interact with each other. All right, so it actually produced this file here. This was my prompt. This is what it produced. And this is because it was a very simple prompt, but for example, if we ask it to have a more complex solution, you will see multiple chat messages. Basically, it's going to try to run the program. If it doesn't produce the desired output, the other agent is going to criticize that, and it will say, try something else. So for example, try installing a missing package. But I hope you get the idea here. And lastly, GraphRag. So you saw that semantic search doesn't always work. So Microsoft is researching a way to do RAG with graphs, essentially. What this does, and I tried setting this up for the demo, but unfortunately I didn't have time to index my documentation. What it does is it takes your documents much like RAG, but instead of searching in them, it tries to index them and to create a graph that connects different concepts using LLMs. So it builds a knowledge graph, and instead of searching, you are then querying the knowledge graph. So you start with a node where you think your result is most probably laying into, and then you traverse the graph to essentially go and consult other knowledge. So it's using knowledge graphs completely, and this is actually very interesting because last year I gave a talk about trying to build software with knowledge graphs. So this is getting much closer to that concept. The idea would be that instead of essentially programming, you're building this knowledge locally in ways that integrate with AI and LLMs. And then you have the tooling build the application based on the knowledge. We are a long way away from that, but already seeing a working implementation of that is quite interesting. Now, thank you very much for going with me through all of this. I hope it was helpful. Any questions and answers, anything you're curious about? No, there's a thank you slide later, but we can wait for that. Yeah, so I'm kind of split on, but that's my personal bias. So I actually had a slide about my personal biases in the beginning, but I didn't want to bother you with myself. But in general, I have a tendency to be biased towards plain text files, and a tendency to be biased towards open source and local, like having the possibility to run everything on your machine. So these are my biases. So that's why I'm not looking into Cursor, but I think it's a great tool. Oh my God, I pressed something. Sorry for that. All right. I also wanted to demo today, what was the name of that tool? There was another one that generates the entire application for you, but I forgot the name. It's an IDE that you prompt it and it creates your project files. Was that? It was similar to that one. Anyway. But yeah, all these tools are great. Whatever works for you and you're used to, you should try to adopt it. I know the team behind Cursor is very powerful. And actually what I'm trying to build is something similar to an IDE, like what you're seeing here, where you can also integrate with large language models. So it's super easy to get something, let's say, average, because you only integrate with text, and we all know how to manipulate strings. So you just play with strings, you concatenate them, and you pass them to an API. That's the AI integration part. Of course, then to get excellent results requires much more. But we have some very specialized and expert models that you can pretty much use in the same, in different IDEs, so the same approach. There's also Continue, for example, I think integrates with JetBrains as well. So if you have the infrastructure and know how to manage your knowledge and code the APIs, you can pretty much integrate with different editors. Any other questions? Yeah.
Two questions, feel free to answer whichever one you like or both.
Yeah.
You said you're a recent convert to the Church of AI.
Yeah.
What made you convert? And the second question is, from as someone who doesn't do AI, I use it a little bit like I assume everybody else. My core concern looking at it is like, how is this thing going to be sustainable when it has to get trained on what will essentially contain other models output, and how will essentially the value part, how will it survive, considering that it's going to get trained more and more on its own data?
Yes, very good points indeed. So let's start with the conversion part. So I'm not the person that thinks that AI is going to replace all of us. And I think that was one of the main reasons of why for so much time I refused to call it AI, even so it was just machine learning. But you can argue that there's really nothing else out there that is able to produce these results. So for me, large language models are just, and I really mean it, just statistics compressed in a file. This is what large language, there's no intelligence, but that doesn't mean that, that's for me, again, personal. That doesn't mean that we cannot use these statistics. At the end of the day, we use statistics for everything else. So we can use these statistics to essentially solve problems that we're facing today. And we can also use them in very bad manners, by the way. I have some terrible personal experiences of people misusing these things, of course. But what made me kind of be more open is that notion of compression being intelligence. Now, I'm not a mathematician, so I cannot go in detail, but I do trust many of the people that essentially share these opinions. So that notion of compression being intelligence, I think, is what mainly made me kind of consider that. But I definitely don't think that without training, we are going to get these essentially what many consider science fiction, like this consciousness. There is no consciousness, probably. There is much more to a human and so on. About data quality deteriorating, that's definitely a problem. So it made me understand the value of data. So I really wondered why people are making money of data or out of data. That didn't make any sense to me until you try to solve a problem. When you try to solve a particular problem, you need to create the statistics for it. And if you don't have the data, you don't have the statistics for it. So that's what's attributing value to data, like besides personal data and so but I don't know what will be the solution for, I think there was a term for it. Do you remember the term? For feeding back the same data, but yeah, that's definitely a problem. Anything else? No? Well, if you want to chat about any of these approaches and what kind of solutions we're building, feel free to reach me out outside. And with that said, thank you very much.